Hey guys, so I'm going to talk to you today about some properties of acids and bases and kind of the definition of what an acid and a base are. So acids are going to be things that start with hydrogen, and in order for it to be considered truly an acid, like HCl, which is hydrochloric acid that's in our stomachs, what happens is when I add it to water, this hydrogen ion is going to be released. So the hydrogen is going to be kind of loose in the water, and then the other part of the compound is also loose. But what will happen is this hydrogen ion is going to find a water to join onto. So the water, along with that hydrogen ion, will become something called hydronium, which is H3O. So it's just a water with an extra hydrogen ion and it's positive. So acids have this hydronium ion or hydrogen ions characteristics. They taste sour and they react with metals and form hydrogen gas. And we will see reactions like that in just a couple days. Bases, for example, sodium hydroxide. When I add it to water, it's going to give me that hydroxide ion. They taste bitter, so think about like soap is a base and it tastes bitter, and then they also feel slippery, and again, soap is slippery. So we'll keep going. Just down here, some common, not a very good image, but bases like baking soda and ammonia. Milk is slightly acidic, I think, due to the lactic acid. Coke and sodas are pretty acidic because they have carbonic acid in them. So here's that definition of the acid, what I was explaining earlier, that they give off hydrogen ions and they make hydronium. So when I'm looking at a compound, whether or not it's an acid, they're going to start with hydrogen. It doesn't matter whether there's more than one or just one, but it'll always be the first, and it'll be the cation. That's just showing you how the acid here, and could be anything. It could be like chloride from hydrochloric. When it gets in water, this hydrogen's going to come off, and then it's going to add itself onto a water and form hydronium. This is hydronium, just a different way to show it. So bases, I already went over this too. Just remember that they produce hydroxide or OH ions when they're added to water. So strong versus weak. So this picture here is showing you, these are hydroniums, so it's like water, but then there's one more extra hydrogen. This would be the other part of the acid, maybe like chlorides. So for this one, here's just a plain water. Actually, those wouldn't have charges, just water. So here's another hydronium. And another. So for this one, there are 1, 2, 3 hydroniums that were formed. And then there's 3 of these anions. 1, 2, 3. Intact acid. This would be the acid. So this would be like H and then Cl. So intact means it stayed together. So there's 1 of those. So this would be a strong acid where most of the acid broke apart. You don't see it together like that. And when they break apart, they make those hydrogen ions, which find water and attach and form hydronium. So let me show you just a silly thing that the coins that Homer and I can't remember his name, are throwing, those would represent the hydrogen ions. So this would be kind of representing like a strong acid or a strong base. So they're just really willing to break apart in water. So here is a weak acid. So again, here's a hydronium. This is just plain water. This is the acid. Here's another water. Here's the acid. And so on. So there's only 1 hydronium, which means only one of the acids like this broke up. So how many hydronium what ions do we find, or anions? We only have one. There's one right there. So this is an example, and then you can see there's 1, 2, 3 of the acids that didn't break apart. It's still considered an acid because it did break apart and give us at least one hydrogen ion here that formed hydronium. But this would be considered weak because only a few of those acid molecules actually donated their hydrogen ions. So this is weak acids. This analogy would be, the cat here. The hydrogen ions would be the money, and it doesn't really want to get rid of its money. So in order for this to truly be an acid, that person, the cat would have to at least give one of its hydrogen ions away. But weak acids are the kind of acids that are in things that we eat, like citric acid, which is what we have that makes this fruit sour, and vinegar. So they're acids, but they don't give many hydrogen ions, so they're pretty, they don't cause us any harm. So here I want to talk about something that we'll be using throughout this term, the terms solute, solvent, and solution. We've already talked about solution, which is the same as homogeneous mixture. This is, something that's going to be mixed throughout. So example, like sugar water, salt water. So solute and solvent are new terms though. Whatever is getting dissolved is the solute. So if I was going to make sugar water, then the sugar itself is what's getting dissolved. That's the solute. The solvent is what is going to do the dissolving, which is water. And a lot of the times, almost always in chemistry, water is the solvent. So here's a little picture. These would be my sugar molecules or my solute. And then surrounding it is my solvent, water. And then if I think of the whole thing together, that would be the solution. So we are going to continue. So when I talk about the terms concentrated and dilute, if I'm talking about a lower concentration, that's dilute. So it just means I don't have that much solute. So if I were to, draw a picture where maybe this is water in here, I'm only going to have a few particles that get dissolved. That's what dilute means. And then higher or lower concentration means. Higher concentration just means you're going to have more of that solute dissolved. So this would be like really sugary sugar water. This would be just a little bit of sugar water. So that's concentration. But what happens is it's possible to have a strong acid that gives up all of its hydrogen ions and concentrated, which means you just have a lot of it and less water. You can also have a dilute strong acid. So you would just not have, it's still strong acid, which means it's going to give its hydrogen ions away. But dilute just means you're going to have less of the acid. It's also possible to have a concentrated weak acid. So weak acid just means it's not going to give up its hydrogen ions very well, no matter what. But the difference between these two is that concentrated means you'll have a lot of that weak acid in less water. And then dilute means you're not going to have much of that weak acid. So strong and weak have a different meaning than concentrated and dilute. This is just the pH scale. So from a pH of 0 to 7 is an acid, 7 is neutral, and then 7 up to 14 is basic. And you can see some examples. So some of these, the stronger the acid or the base, and the more concentrated it is, then the more dangerous it is. So pH is just a scale that helps us to measure the acidity of the sample. Different ways to measure pH. We can use liquid chemical indicators, and these will change colors based on the pH of the substance we're testing. Universal indicator is one of these. It could be either on a paper. We can put it on a paper and let it dry and use it, or it could be liquid. So there's also like litmus paper you've probably used before. So the papers are coated with some kind of an indicator, but then it's dried. pH meters or probes, we can use these too to electronically determine pHs. And that's all I have for today.